Hey guys, okay, I thought number 5 was sneaky and mean. So here we go. A burger shop serves veggie burgers and chicken burgers. Each customer will choose one of the following 3 options: buy only a veggie burger, buy only a chicken burger, or buy both a veggie burger and a chicken burger. Okay, so I see only one thing, and then both. That is giving Venn diagram, right? I have one side that's only, one side that's only, and then I have the intersection of the two. So I think this is how I'm going to approach this problem here. And the two things that I'm talking about are veggie burgers and chicken burgers. Okay. The probability that a customer buys a veggie burger is 0.65. So that's like a veggie burger in total. So remember, there's going to be some little piece in the middle that I'm going to have to subtract off, right? Let's call that X. And then the probability that a customer buys a chicken burger is 0.54. And then there's also that shared probability in the middle X that I'm going to have to subtract off. Okay, so keep that in mind. Find the probability that a customer chosen at random will buy both a veggie burger and a chicken burger. Okay, so veggie burger and chicken burger is going to be that little piece that's right in the middle there. It says that the burger shop serves only veggie burgers and chicken burgers, and that each customer will choose one of the following 3 options: only veggie, only chicken, or both. So that means that every single thing in this Venn diagram has to fit in V or C. So that means that if I add them all together, 0.65 minus X plus 0.54 minus X, they should all equal 1, because everything must fit in between these two circles. Okay, so now these end up canceling, and I am going to be left with 1.19 minus X equals 1. Okay, so now I know that that is the piece in the middle, and then 0.65 is going to give me 0.46. All right, I got my Venn diagram filled out. I feel better. I feel like once I have a visual plan of attack, I'm always in a much better spot. So the probability that someone is going to buy a veggie burger and a chicken burger is going to be 0.19. Probability of only a chicken burger. Okay, now this problem just got so easy, right? So I'm going to cover up the whole V. Let me see if I can erase this without ruining it. Oh yeah, I can. I'm going to cover up the whole V circle. What am I left with? Only chicken. That's 0.35. Okay. On a typical day, 600 customers come to the burger shop. Fine. The expected number of veggie burgers sold on a typical day. Okay, so there's no probability distribution here, so my expected value is just going to be found by multiplying N times P. So the expected number of veggie burgers sold is going to be N, which is the 600 customers that come in. And then the probability that you buy a veggie burger in total is 0.65, right? And they're not saying just a veggie burger. We're also including that piece in the middle. That still counts as buying a veggie burger. So I would do that with my calculator and get 390. So they'd be expected to sell about 390 veggie burgers. No, my highlighter's frozen. Okay. Come on. Okay. The probability that, more than 400 veggie burgers will be sold on a typical day. Okay, so more than 400 veggie burgers. I'm thinking that the probability of selling a veggie burger is probably going to be my probability of success, right? That is the veggie burger being sold. That's the success. And then more than 400 veggie burgers, it's giving a range of successes, right? So there's 600 in total, right? So that's the upper limit. I could sell from 400 to 600. Okay, this is giving binomial CDF. And let's see, N is going to be the number of trials. Yeah, okay, this looks good. So I'm going to say the probability that we sell more than 400 veggie burgers. See how we're not including 400? That's interesting. So if we're not including 400, I'm going to have to change this guy to 401. Okay. All right, so more than 400 veggie burgers, yes. Let's use binomial CDF. This looks like a good idea. Okay, so what am I going to type in my calculator to show my work? Menu, 55B. I've got 600 trials in total, right? The probability of success or the probability of selling a veggie burger is 0.65. The lower bound is going to be 401 because I need more than 400. And the upper bound is going to be 600. So that is going to be around 0. I'm going to write down the unrounded version and then round. I like that because then I could see if you are rounding correctly. So definitely show that. So I've got the probability that x is greater than 400. It's going to be equal to 0.184624. Okay. And then now I'm going to round 0.185. Cool. It is known that 44% of the customers who come to the burger shop are females, and that 75% of the female customers buy a chicken burger. Okay, so I'm seeing first event, being a female or not being a female, right? And then I see a second event occurring where a female buys a chicken burger. Okay, so it's giving probability tree now. Do you see how you're using all these different methods to figure stuff out? Okay, and then now they can buy a chicken burger or not a chicken burger or not a chicken burger. All right, let's try to fill this bad boy out. It says a customer is selected at random. Find the probability that the customer is female and buys a chicken burger. So that's going to, come on, give me a different color highlighter. Oh, gosh. I would like one. Here we go. So female and buys a chicken burger. I'm ending up on this branch here. Let's fill this out. It is known that 44% of the customers who come in are females, so that means I'm going to have 0.44 here for female. Not a female is going to be 0.56. We don't need that, but I'm just making sure we fill this thing out. And then 75% of the female customers buy a chicken burger, so that's going to be up here. Oh, cool. So this would be 0.25. I don't even need to figure out the other one. They don't even give it to me anyway. So I'm just going to zero in on this spot right here. So the probability that you're female and you buy a chicken burger, that's going to be 0.44 times, what was the probability of getting a chicken burger? Oh, they give it to me right here on the tree. There we go. Times 0.75. Cool. .33. Hello, sorry, this is a merge. Someone came in and started talking to me. Okay. A male customer is selected at random. Find the probability that he buys a chicken burger. Ooh, a male customer is selected at random. So that means of the males, this is a sneaky given. Of the males, in this case, we've referred to them as not females up here, right? Find the probability that he buys a chicken burger. So let's look at the formula and see where we have to find all this stuff. Given goes down below and is on top. Okay, so I've got the probability of being a male, or in this case not female, is 0.56. Sorry, I see that right up there on the tree. However, chicken and not female, that is a little bit of a thinker, huh? I have up here on the probability tree not female, but then it says nothing about who buys a chicken, who doesn't buy a chicken burger. I'm gonna go look up at the Venn diagram up here. It doesn't give me a breakdown of males and females who buy these chicken burgers, right? I do know that the total probability of buying a chicken burger, however, is gonna be 0.54, right? And just like reasoning wise, I know that this is going to be comprised of all the females who bought a chicken burger and all the, sorry, trying to erase this parenthesis here. Come on. Okay. And all of the non-females that buy a chicken burger. So female and chicken burger, I know that. I just found that up here, so I'm going to use that, the 0.33. But I do not know this. But that's okay, because I know the other two things, and I can just solve for that unknown probability that I need right there. So I'm going to subtract off the 0.33. I'm going to get 0.21. And actually, that's exactly what I need for the formula. So, woo, I found it. That's going to go on top. And then I'm just going to divide. And I get 0.375. Woo! So let's button this all up so it's easy to read. And we're